questions.
Of course.
Or maybe while it compiles.
You have
Well, yeah, when it compiles, yes. That's when you take your break and touch grass.
no, but you have vulnerabilities when you Rust.
Oh,
It doesn't mean that it's vulnerability less.
I don't know, I'm a JS developer anyway, so.
You take a break while you're prompting the LLM, which I'm not doing this talk, by the way. I don't do AI.
No, but the trick is to prompt different threads. That way you can check each thread when they're done, so you don't have to take a break, you just do more.
You AI developers fascinate me and scare me at the same time.
But you can merge both. Like, I think that's one of the biggest advantages of migrating to Rust is letting the agents write the Rust, which they do pretty well.
Let the compiler work for you. The compiler's good enough. Okay.
No, that's true. That's
Alright.
one of the biggest advantages.
Indeed. Oh, the door opened yet again. Another convert. Good.
Not yet.
Huh?
Not yet.
No, well.
In 1 hour.
Yeah, coming to
Or
that point.
45 minutes.
Okay, so I think everyone who wants to be here is here. The rest are having lunch break. So to everyone who is here, thank you for sacrificing lunch. Okay, so a bit about me because there's a lot of new faces. We had to replace that picture, Ma. I've got a much bigger rack now. 42 used as a client inside and stuff. Yeah, but anyways.
You've got longer hair,
And that too.
but still the same t-shirt.
Yes. So, this is a bit about me. I'm Alex. I do Kubernetes stuff. I'm one of the co-organizers of the Cloud Native community in Mauritius. The co-organizers there, my mom. Hello, Ma. These are some of my stuff, my website, Mastodon, that needs to be changed as well, and GitHub. My website's down because my Rabbit ate my fiber cables, so the only one which works right now is GitHub. I do Kubernetes, I like Linux and free and open source software, and one of my hobbies is playing with the home lab. So I don't have a life. I work in IT at work, and then I work with IT when I get home. Right. So let me complain a little bit. Modern software, I think everyone has that problem nowadays. Modern software is very bloated and inefficient. In a lot of cases, we treat optimization as an afterthought and not something we want to build into our code as we're building it. Code is written to work first, and we say we're going to optimize it in the future, we're going to make it better in the future. As everyone who's in IT knows, saying I'm going to do this means I'm never going to do it. It works, the manager's happy, KPIs are being met, that's all. So these are two screenshots I took while I was creating these slides. The first is a Discord client, so for those of you who know Discord. And then the second is Chrome, which I opened. There's nothing running, no YouTube, no nothing. It's just Chromium running. And so you can see how much memory is being eaten in both those cases. And this makes me sad. Because Electron, at the end of the day, is the default for a lot of desktop apps. And Electron is based on Chromium. It's the whole reason we have so much memory usage in applications which we use. Duck typing and garbage collection. So is anyone not familiar with duck typing or garbage collection here? Well, you will be soon. While it's not immediately noticeable to the programmer, it also contributes to slow code. And in fact, quite a while back, there had been a study, I think it was Cloudflare, which initiated the study, to study the impact of programming languages on efficiency, yes, but therefore on greenhouse emissions. Because surprisingly, if you write something in C, which is very performant, very fast, it's going to produce a lot less greenhouse gases or a lot less climate impact than something like Python, which takes a lot longer to run. So you also have memory inefficiencies, so if you're running anything at scale, those memory inefficiencies will scale up very fast, and then you're going to be paying a very big cloud bill at the end of the month. So for a lot of time, devs have had to choose between either dev friendliness, i.e. Python, JavaScript, PHP. If I named your language in these three, raise your hand. JavaScript includes TypeScript, by the way. So yeah, but anyways, you choose that over performance, i.e. C or C++. But it doesn't always have to be this way, right? So I wanted to introduce Rust in this talk, and I'm glad that so many of you are interested in this programming language. Rust is somewhat of a more recent language. It's at least a lot more recent than Python and way younger than C, for example. So it's built to fit a very specific niche. It wants to be as performant and fast as C and C++, but as we all are all familiar, C and C++ are familiar with, are prone to bugs. Or on the other hand, it wants to also maintain the usability of Python, JavaScript, Java, but those programming languages themselves are slow and resource hungry. Of course, they have less bugs. So for the time being, you've got to make the choice. Do you want to go fast development, admittedly slow, or have bugs everywhere, right? I know a lot of people here in Mauritius, they learn, or at least in most universities, you learn C. How many people who have gone through university and learned C would say that I'm proficient in C?
Yes.
Yeah, Ma, you lower your hand, you're old. So Rust, at least the rumor has it, that it started as a personal project which was born because the guy got stuck in a broken elevator, and that elevator had memory leaks or bugs of some kind, and so he was tired that every time he had to take the stairs of his apartment. Rust used to be sponsored by Mozilla, and since 2021 there's a whole Rust Foundation which has taken it up. Of course with some controversy, but yeah, since 2021 the Rust Foundation has been the leading organization behind Rust. And I'm sure all of you have been following the news. Rust is everywhere. Rust, I mean, everyone's rewriting it in Rust, right? That's the new meme. So Rust appears everywhere. It's in AWS with S3. Everyone's familiar. S3 had a major breakage. That was Rust. It appears in Linux, the Linux kernel. The Ladybird browser. Oh, I said Cloudflare right here. Yeah, and Cloudflare. There's some others as well. I think Git now by default it ships. It requires developers to have Rust in their toolchain. Okay, so that's a bit about Rust. I'm not showing you yet the intricacies of writing Rust, but some interesting facts. So, what makes, for example, Go, Java, Node, Python, and such so appealing to developers is that there is a garbage collector, which cleans up after you. C, C++ does not have a garbage collector, but Rust does not have one. To enforce memory safety, it goes through this thing called ownership, and I have slides on ownership in a little while. Rust also compiles to a binary which is as performant, as lightweight as C. And in my opinion, and I think after this talk you're not going to disagree, it has the world's best compiler, which
There have been better ones now. It was the best 5-6 years ago.
I don't know of any which are better than Rust.
Mojos is better than Rust.
Which one?
Mojos is better than Rust.
Is that a programming language?
Yes.
I've never heard of it. Talk for next year. So it's got a great compiler. It has detailed errors, suggestions, warnings, and everything you could need. So just going through the compiler output, you can say, why do I need an LLM? Why am I paying $100 to code every month? The compiler will replace it. All right. It has a package manager, tests, formatting, docs, yeah, all those nice features of a modern programming language. So at this point, you'll be like, well, Alex, why do I not use Rust? And good, you're on the way to being a cultist like me. All right, so let's write some Rust. Rust looks kind of like this. I guess it's familiar to some people. So let's open the terminal. I'll increase the font size. Yes, there's a cat in my terminal. That's what outputs when you do cat. Okay. So let's just do the main.rs for the time being, and you can type in something like fn function main, and we're just going to print. So very simple code. Everyone does this. Everyone knows how it works, right? And then Rust C main RS. Rust C is a very simple, I guess, compiler for your Rust code. And then if I list, main.rs has been compiled down into main. So you can actually just run main, it's an executable, and it's going to run. Cool. So we've written, or at least I've written, my first bit of Rust. And I hope all of you will go home and start with this wonderful adventure right after that. Okay. But Rust C, which I showed you just now, it has some drawbacks. It's not the thing which you're going to use to manage dependencies, for linking libraries. If you want to build flags, it becomes very complicated. So Cargo is, I think, from my understanding, I'm not a JavaScript developer, it's Rust's version of NPM or pip. Pip being for Python, NPM being for the JavaScript ecosystem. So Cargo comes with package manager, the build system itself. It can run tests and generate logs, all just from Cargo. Of course, Cargo, I already have it installed here. So let's go to the next slide. Cargo, you create packages. So for example, here I've started out with Cargo new demo. So let's go here and remove everything. Okay. Let's start off by creating a demo. So Cargo create, and I'm just going to say demo and new. So when I've done Cargo create, it's created this demo folder for me, and in it I've got a cargo.toml file, which is what Cargo uses, as well as a source directory. In this source directory, you just have main.rs, which is pre-filled like this. We'll get to this a little bit more in a second. Cargo, as I said, it gives you the package management facilities, so you can do where that is. DevCon 26. I didn't create it in because last night. That's why I'm fat fingering everything. Okay, so you can do, for example, cargo add and log. In this case, if you want a logging package, it's just cargo add log. And you'll see it's going to add it. It gives you some features. And then we'll see in cargo.toml that in the dependencies, which was not there before, now all of a sudden you have log. All right, cool. So I've got a bit ahead of things here, but all right. So similar thing, cargo log, you get in your cargo.toml. So now I wanted to go a little bit over the Rust syntax, variables and immutability, functions, structs and enums, pattern matching, and then using libraries. Okay, so fingers crossed. I didn't write anything down ahead of time, so we'll work through this together, right? So in my cargo package thing installed here, we already have print hello world. Now, if you want to, let's say, have a variable, you're going to define your variables by let. So let x equal 5, for example. And then you'll see NeoVim is going to automatically add I32 here, which is the type. I means it is signed and it's a 32-bit number. Right, so after that, we can just do print and number is, and then x. And then over here, you just do cargo run, which is going to compile, and then you have hello world over here. Cool. Wait. Oh, I did save. Okay, so yeah, now that's fine. Right. That's a bit low. Cool. So that's for numbers. Now, if you want to do x equal x plus 2, for example, yes, be quiet, NeoVim. I don't want to show you already the errors. If you do cargo run now, it's going to say, well, there's a problem. This is where the really good Rust compiler comes in. So it sees that we've already created the variable x and assigned to it. Now, later on, we decide we want to change the value of x, but it cannot assign twice to an immutable variable. And this is one of the features of Rust, where by default, your variables are all going to be immutable. If you want something to be mutable, you'll see it gives you very useful help. Consider making this mutable. So indeed, you go over here, get mute x, and then cargo run, and it works. So that's for immutability. Functions, I'm sure you guys have already seen, we've got the function main over here. Actually, I think I know how I'm going to do this. Okay, so we're going to have something which says hello name, and we're just going to have a function which is going to output the name. So we just call it output hello. And this function, what it's going to take is a name, which is going to be of type string. That's your function, much similar to main, except that here it's taking a parameter. And then we're going to do println. Which means we're going to move the print function from print statement from the main function into the output hello function. So we're going to say let name equal string from. I'm going to put my own name because I'm the presenter. And then we're just going to say output hello name. And we already have a name variable. Alright, cool. So if you do cargo run, it's going to go back in the corner again. And cargo run hello Alex. Right? Okay, let's go for structs then. Because me in the past made the slides, thought it was a good idea to talk about structs. Structures, well, everyone here is probably familiar with object-oriented programming. Rust is not an object-oriented language. Instead, you have structs to deal with. So, for example, I'm going to define struct, and struct person is just going to be have a name, which is of type string, and an age, which is of type, let's say, it's an unsigned 32 bits. Okay. Then in our main function over here, we can say, we're going to say let Alex, which is me, be a person, and then we're going to create it by specifying a name. So the name is there's a reason I'm actually doing string from and not just putting it in quotes. I'll get to that in a minute as well. And age I'm 22. Yes. Okay, and we also edit the output hello function to, instead of taking just the name, it's going to take into consideration a person. The photographer is not here, but this is still flashing. Alright, so this means that output hello is not going to be taking a name of type string anymore, it's going to be taking a person of type person. And then we're not going to output name, but we're going to output person dot name. Cool? Now, why are you complaining? Field access. Oh, field access is supported. Is it this which is the problem? Okay. Okay, so once again, the Rust compiler is giving us some very useless warnings. It's just about, well, this should have a proper upper camel case name because we want to write clean code, right? And age isn't used, but that doesn't matter. At the end of the day, it's still output. I keep on hiding my own output, so yeah, it says hello Alex at the end. So that's for structs. Enums are done in a similar way. Let me just clear all of this out. Enums are very useful in Rust for error handling. Because you'll see actually that, well, we'll see later on, that Rust forces you to actually handle your errors in an intelligent way. In Go, at least from what I remember, it's that you have a lot of if error equal nil, or if error not nil, and then you go through there. Here with Rust, it forces you to do things a lot more intelligently and actually handle your errors properly. And pattern matching. So I'll show that one as well during the demo, as well as using libraries. Okay, that's so far so good. Okay. Presentation mode, yeah. Okay, fine. Let's start like this then. So there's a problem. In C and C++, you have a lot of manual handling of memory. For the old people here, if I recall correctly, C has a lot of malloc, memory allocate, and then you've got to free your memory at the end. Handling all this memory manually means that if you're a bad programmer, as I think most of us here are, you are prone to having memory leaks, double frees, or use after free, where you free memory, but then still use it afterwards. So, as you can imagine, that's causing problems because you're reading from memory, which is no longer the variable you initially had there. Garbage collection, which is what a lot of modern languages use, it's safe, yes, because you're not going to shoot yourself in the foot, but it introduces a lot of runtime overhead and a lot of unpredictable latency. Now you see, Rust initially was created by the guy because his elevator stopped working, right? You don't program elevators in Python or JavaScript, unfortunately, or no, fortunately. So instead, Rust is, I guess, targeted towards being a systems language. So something you program systems with, like your Arduino, or much lower level stuff, which is also why it ended up in the Linux kernel, right? Of course, it's not just used for that, it's used for a lot of other things, but I guess that was the main focus point when Rust was created. And having these kinds of latencies or the extra overhead from memory management through garbage collection, that's unacceptable on like microcontrollers, integrated circuits, and the like. So Rust introduces ownership, where each value has an owner. The value can only have one owner at a time, and when that owner goes out of scope, the memory is automatically freed. So you don't have any point where you have to manually write free memory or other kinds of memory wizardry, right? So, okay, I did write this, and it is in another folder. So, let's just go through. Okay, it's still here. Again, it's outputting the error value. I don't want it to output the error value. You need to learn for yourselves why it's bad. Okay, so I've got this function called borrowPrint and this other function called ownPrint. And you're going to see that they're both identical, except for the parameter. In one, it's taking this ampersand string and ampersand, right? That's it. Yeah. And then another one is just string. So the thing about the first function, by having that symbol in front, it means that it's only borrowing the value. So when the main function, which has defined the value initially here, is going to pass it into borrowPrint, borrowPrint is going to say, oh, thank you for that value, thank you for that memory allocated already. I'm only going to use it temporarily, and once I'm done using it, ownership is going to return to the parent function. So that means after borrowPrint runs, S is still a valid thing. However, after ownPrint, which does not have that borrowing, it actually takes ownership completely. It says that, all right, thank you for the value, it's mine now. And after it's output it, when it reaches that curly bracket at the end over here, it's going to say, oh, well, I have this own value, it's mine. We've reached the end, well, I'm going to get rid of it. So that's one of the things about the memory ownership and borrowing of values. And that's why you can see the checker is giving me a bit of a complaint at the end here, because S got passed into ownPrint. ownPrint now owns S, and then after ownPrint runs, S is just removed. And so therefore S is not a valid thing to be used afterwards in borrowPrint, which is why if you're going to go here and do cargo run, because I'm going to ignore the fancy ID errors. So once again, the compiler is very useful because it means even if you don't have a very smart editor, it's going to explain to you exactly what has happened and why. So let's say, well, print s, the value was moved here, but then was used elsewhere after the move. So it says, note, consider changing the parameter type in function onPrint to borrow instead, if you need to use that value after that function is called. So in some of the code that I've written, I'm not going to show that brush right now, but in some of the code that I've written, for example, if you have a database, you've got the database pool which is created at start, you want to only hand out that database pool to the functions which are running it, right? But you don't want those functions to drop the database connection after they've run. So by having those functions only borrow, your database connection, all your functions get to use it and be happy at the end. And it's not just one which is going to use your database and say, don't need it anymore. Another option, and this is really good if you're just starting out with Rust, is you can do this thing called .clone. .clone is basically going to take your value and it's going to create a clone of it, which now means you do have two values, which does mean more memory use, but we've seen how much people care about memory. This code was using 600 megs. I had to close everything just for this talk. I needed to be sure it would run smoothly. So if I disable borrow print at the end here, you can see compiler very happy, and when you do cargo run, good, it runs. Another way of doing this, if you really insist, is that you can actually just return the string at the end. So here I'm changing onPrint, so it's going to output text, and then it's just going to return text. And then you can say over here after onPrint, just say let s equal, and then you can run this again. Because now it means that after onPrint run, it still returned the value, and you can just pass the value back into borrowPrint again. It works. It works, but higher up my screen. So that's a bit about ownership and borrowing. Let's continue with slides then.
Next.
Yeah.
When you borrow,
Yes.
is S as you have in your code, can it be changed by borrow print, or is it empty?
So if you can, though in that case I'd have to say mutable s, and then borrow print would have to actually, instead of taking just the string, would have to say it's taking a mutable version of it, and that's not the right. Is it? I think it's this. Yeah. So now you can change text inside. So if I want to say so we change hello to world.
Not the right order.
No, I want to change it from hello to world, so that when onPrint takes it, it will output world instead.
It's not the same string.
Yeah, I know. Can I just... Does that work? No. Because I know if I do that as ref, it's going to put it as a... Then, Rust expert, no. Okay.
Why don't you invert it? Put the to the string mutable before printing it.
Sorry, what do you mean?
Add something to a mutable string before printing it.
What do you mean to have? No, because I still can't change it because it's taking it as a the root string, but then I'm assigning. Oh, let's. Oh. Let's see. What does it expect? Found. So that's not a right concat. Like this. Maybe it's work? No, I don't have to name like that. Okay, but to answer your question, Mark, yes, you can modify it inside there. But the other thing is, for the sake of this demo, I pass it as like string capital S, whereas what you usually do is you pass it as a string slice, str. A complication with Rust, indeed. Are there any other questions right now, or have I lost all the JavaScript developers? All good? The lack of answer is scary. Alright, so this was about borrowing, and we have time. So I wanted to have a look at web development in Rust, because that was actually the intent of this talk. I was playing around with this framework, and it was like, oh, this stuff is cool. So a little bit of background actually. I run this website called meetup.nu. It runs off my home lab. It's not running right now, but that website was initially developed in PHP with Laravel. Big community effort, a lot of people contributed, but it's PHP and Laravel. So at the end of the day, I had to deploy it to my home lab, and I said, okay, I'm going to create a container, I'm going to run it. It's fine, it runs, everyone's able to access it most of the time. And on my end, though, it eats some 350 megs of RAM just idle. It's not doing anything, it's 350 megs of idle. What does a website, what is Laravel, PHP, or whatever doing with 350 megs of RAM for nothing? So, and also, memory prices have gone up recently, so that's another thing. I'm very unhappy about that. So I was doing web development in Rust, because I was on the Rust subreddit one day and someone said, look, we have an alternative to Laravel in Rust. I was like, okay. A lot of stuff is done in Laravel, by the way, especially in Mauritius. Like, I know the Express, for example, runs on Laravel. Can you imagine how much RAM that is being wasted? Okay, so let's have a look at the state of web development in Rust. There are a lot of individual components. There's Actix Web, Axum, Rocket. In fact, I made a project. So I'm going to be talking about this project on Saturday, and you'll see in here all of this code right here, it is a web thing. There's APIs, right? So you've got authentication thing here. Oh, that's not the one we want to show. Okay, for those of you who've run stuff in Flask, I guess, and know the alternatives for the languages, this might look a bit familiar. So this project was created using Actix Web. But as you can see, there's so much, boilerplate. I've got to write this in my main.rs. I've got so much stuff. This is me implementing middleware. If you can't read it, yeah, we're on the same team here. It's painful. So yeah, there's a lot of stuff which is, let's say, unnecessarily complicated. So yeah, as I said, these are micro frameworks. They're similar to Flask. What other people might relate to it, I don't know. So it's fast and flexible, yes, which is why I used it initially. Also, I was young and stupid, but alright. But you need a lot of additional assembly for things like ORM, templating, authentication, sessions, database migrations, the stuff that us modern software developers really like, right? So yeah, complex setup, painful boilerplate. If I showed you this project, it would get you to run straight out of the door, right? And I make up a new joke there. So, what do we actually need? Well, we need something which is a framework which has everything included. Similar to Django, so Python people, hello. Laravel for the PHP people, no one here. Or Rails. Now, you see the Laravel people did not show up because they think they're superior. They don't want to be educated. Okay, anyways, it brought me to this project called COT, and COT, I think, is, in some language, this is funny, presentation mode just went in another window. Okay. So yeah. Cat means cat in some language, of course which one. And yeah. So cat has a few principles coming out of the box. So Rust types and structures, which as you saw, like the typing is really strong, it forces you to pay attention to the code you're writing, and you start your code with X is an integer, and by the end it's a complex class with inheritance and all of the other things. JavaScript people? Hello? So it uses those as a source of truth for query validation. With your database, you can use it for form validation. I mean, the entire Rust safety mechanisms also apply to code, and you can make your websites with something this powerful and this robust. Database engine agnostic, which means that you can bring Postgres, you can bring MySQL, you can bring Microsoft SQL if you insist, or SQLite, and it'll auto-generate the migrations for you. Another cool feature is it comes with a built-in admin panel, so for all your CRUD operations, you can just enable that on your models, and then have really easy admin access and that. Automatic form validation, so again, type safety, you can define your structs to have something, it's a string, it's a limited string, it's an integer, or it's a date, you can enforce that. You have built-in authentication with sessions, auth, and security middleware. You see, I'm not really a web developer, which is why I'm looking at my slides right now. And you also have the Open API and Swagger docs generation included, so it packages everything really, really nicely for you. So is everyone convinced now? Okay, so let's do what we do best and rewrite something in Rust in 10 minutes. So let's create a new directory. A new pod, DevCon here, and going to open this in a proper big boy editor. Open here. No. Create a new instance just for you. Alright, so if you want to get started with Cot, you guys can see this? Okay. I'll tell out the commands I'm using anyways. So you've got this thing called Cot CLI. Is it? No, just Cot. If in doubt, always just append --help to your commands. Okay, Cot new. Okay, then I created a project. Cot is actually a project which is still in beta, I think. Always looking for contributors and people to write docs and small stuff like this. So if you're interested, check out the project. I have contributed in the past, and I'm rewriting their docs because I don't think their docs look that nice. Okay, so Cot comes with a lot of stuff ready. Now, you saw my other project, I had to do all of this by hand. I wrote my authentication by hand, which means it's not secure. I had to do the database stuff by hand, which means it's not secure. Anyone who wants to try to SQL inject my website, go for it. Okay, and at the end you get the website, which should run. I mean, it creates a lot of defaults. So let's see. It's going to compile. For those of you who aren't familiar with the Rust ecosystem, the compile times for Rust are very, very long, which means now is usually the time you go have a cup of tea, touch grass, talk to your family. And I'm stalling and it's not done yet. Still compiling. Anyways, how's everyone doing? Any questions so far while this does its thing?
What is Beacon? Is it the process manager?
Process manager. I'm not a developer.
So Beacon server.
Yes, Beacon server, it's like npm serve, I guess.
Okay.
So it's a really cool thing for in development because it also gives me the live reloading. If I went with cargo instead, you saw I did cargo run earlier, cargo run, cargo build, it means that every time I make a change, I'd be running cargo build and it would have to do this whole process again. Whereas now it will maybe only compile the things which have changed and then reload immediately. There's also another thing about Rust, not a good point, I'm going to say, is that I think this is the next NPM of vulnerabilities. You see how much stuff is just being imported? You don't know, what is Tower cookies? Right? What is Tower sessions memories? Right? There's so much stuff in there. Yeah, I think you are slightly at risk when importing a lot of crates from cargo.
So what's the thing with Deadpool? Like, you see some agent doing security work for you?
Where you saw Deadpool monster?
Yeah.
Gives you like the oh yeah, Deadpool right this. In my opinion, it's probably a connection pool. If you don't want to be dead.
So when installing everything and combining everything in terms of resources and memory usage, do you have any control over that, or it just goes?
You can actually have flags to control this. Right now, if I'm going to look at it, it's going to be my laptop's asking for me to call a fire, an ambulance or fireman. Rust analyzer 2.4 gigs. I said we have a problem with RAM usage. In production, on my laptop it's fine. Okay. CPUs are turning, that's how you know it's doing its thing. Oh, it's run. Okay, great. Can I just run Firefox? I hope I did not leave any embarrassing pages open. But someone doing Firefox, it's on my main browser. Oh yeah, sure, I've just done Chrome. Okay, so if you go to HTTP, localhost, and then we'll port 8080, I think. No, 8000, wrong. 8000. Ta-da! You've installed COT and you've made it through the long compile time. Congratulations. Thank you. You guys have no idea how hard it is to entertain a crowd while Rust is compiling. Okay, we've got more or less 5-ish minutes left, so I'm probably not going to do the whole rewrite. Instead, I'm actually just going to show what I already wrote. Okay, you can be quiet now. Calm down. Yeah, now it's calming down. Great. So this is a project I wanted to work on quite a while ago, and just using it. So, is anyone here not familiar with the website meetup.mu? Oh, we had one. You have the courage to raise your hand. Okay. Just one person. Great. Meetup.mu is a website that I created to aggregate together all the meetups which happen in Mauritius. Because you've got front end, you've got Python, you've got Cloud Native, you've got MSCC, you've got so many communities organizing stuff, it's hard to keep track. Anyways, that's the backstory. I show you, but a rabbit ate my fiber optic cable, so I can't show you. Instead, I have it locally, right? This is still the old design, i.e. before Sandy asked Claude to make it look nicer. Go here. It's also already got old data, but that shouldn't matter. You see, it gives me all these warnings, but I'm blind. I don't care about warnings. Here, Mauritius Tech Meetups. That's what the website used to look like. Very ugly. You can see I had a fun time testing this. So normally these would be replaced by actual proper meetups. Let's have a look at how that website is made. Yeah. So it's actually a very simple website. On the homepage, all it does is looks for all meetups which are happening in the future, and for the past page, which is what I was looking at here, these are all the events which have happened in the past. For everyone who's done development, be it in .NET, be it in Python, be it in whatever, you know this is really simple. It's one query. Select from database where date greater than today or greater less than date let's start today. So you can see actually, let's have a look at the index view. So index view takes a few parameters. It takes your database, some static files and URLs. And what does it return? It returns HTML. Okay. All of this is, somewhat boilerplate code. I'm just going to say, okay, current date is going to be in that format because that's what's in the database. We're going to say we're going to run a query on the meetup type, and this is a great time for me to show you models and meetup. There, you guys can see. Great. So when doing this, I reference the code from Laravel, and this is what the model looked like in Laravel. You see, you have table ID, table string of which has the field name, type, community, title, and so on. And you've got nullable, you've got some defaults and stuff, right? When rewritten in Rust, this is what it looks like. So an ID is just an automatically incrementing I32. Type is a limited string, so 255 characters max. If you want text, it's just string. You have option. Option means it's nullable. It can either be none or it can be a value. And then date is just the date. Cool. So that's actually the whole model just represented as a Rust struct. And you can see there's a little thing on top which says it's a model. So it knows that the COT will know to refer to this as a model, which also lets us create migrations. Migrations is another thing. And you're seeing this and you're thinking, wow, that's scary. It created that for me. I didn't have to. It's just COT migration make, and it creates the whole thing for you. So it's going to base itself off the models, and it'll say, okay, well, we've got that model, which needs an ID, which has a type, a community, a title, an abstract location, and so on. And it's just going to say, and it's as a COT database field, which is nullable, or maybe it's a limited string, so on. So I think that should be fairly simple. If you've done Laravel, it's a PHP artisan migration make or something like that. Similar concept, it's done for you. So imagine if I had to write all this by hand. That's why I don't do development. So back to the controllers actually. So here when I'm doing the query on meetup, it means you are taking that meetup model and we're going to create a new database query based off it. And we're going to say, all right, meetups, we're going to filter greater than. There's progress to make this more readable, by the way. Greater than on field date and current date. So the values in the field date must be greater than the current date. So that's how you know future meetups. If you want to know today's meetups, you do the exact same thing. Just instead of saying greater than, you want to say equal to, EQ, equal to current date. And then we're going to create a template using all of this information that we've created, meetups, today's meetups. We're going to render it, and then we're going to output it. Cool. And this is all you need. But when you say OK HTML from the rendered HTML, that's what appears in your screen. So something also I wanted to show is the templating. And let's have a look at the layouts. So we've got a main.html. Yeah, seeing this, I remember why I don't do front end. Okay, this is the important part. We have a block which is navigation, a block which is today, and for every meetup in our list of meetups, we're just going to include a component which is card.html. And we will go over to components, card.html. You see, again, I did not write all of this. Sandeep did when he wrote the first UI for meetup.me. You're going to say, for example, this is where meetup.community gets substituted. The abstract text goes here. The location goes here. You see these kinds of things. Or you can even have conditions. So if the meetup has a location type, because not all communities will have a location on their event at the time of the event being created. So sometimes location is just null. So if it's null, then you don't show all of that code. Simple stuff. And then you have meetup.type, registration. So if registration is open, i.e. there is a link to register at, it's going to display that. Otherwise, it's not going to show you registration. So it's just going to output this. Yeah, basically it's just that. This is the index thing, so it extends your main layout. We have a block for today and a block for navigation. That's all. It's actually very simple. Okay, and finally, last thing I wanted to do. Let's run btop. And let's filter by, I wonder if it's going to be vacant. Okay. Remember how I was complaining about memory at the start? This uses 13 megs of RAM to run a website. This is how it was meant to be. Not 350 megs. Because nobody's paying for my server. Okay, and lastly, while it's still running, it is running in debug mode, so it's not going to be the best performance. Let's run this thing called OHA. OHA is used for stress testing, and I'm just going to hit it with a barrage of requests and see how it can handle them. So, here's a second. A few very short seconds. My laptop is not the best laptop, and at this point you're going to see it's still using only 13 megs. It's still using only 13 megs of RAM, even though it is using all my CPU. But I think CPU is cheaper than RAM in this economy. So, they're fine. Okay, I'll just answer it. Yeah. What can we infer from this? We can infer that everything is in the green. A reminder, my laptop is not great, for starters. It's an i7 from probably at least 8 years ago. For second thing, it is running in debug mode, so we do not have the same performance. Usually, when I run it on my desktop, in production mode, you had a millisecond or two. Here it's 20, still more than acceptable. Requests per second, we did 3,600, which I think is a lot. And in that time, we sent across 1 gig of data. This is a lot, and if I had more time, I would have compared it to. Actually, hold on. Let's see quickly. This won't take long. Yeah. PHP artisan serve. 8001. So we'll run OHA on 1001, not for 60 seconds, we'll just do 30. The laptop has not changed. And PHP Artisan Serve is also sort of debug mode. It's not production. So what if I'm not running in production? Not the best test. Let's see. Okay, I got tired. Comparing Rust's version at let's say 20 milliseconds of response time, we are now looking at 1.1 to 1.2 seconds, not milliseconds, seconds of response time. In a period, we did only 43 requests per second. Why is this so inefficient? So I just wanted to talk about this. I think it's a really cool project. I'd be happy to talk more about it. If you find Rust interesting, you can refer to Rustlings, which is a really good step-by-step thing where you work through it, or the Rust book, which is the Rust Bible, basically, of learning everything there is to know about Rust. So, any questions before I finish? Yes?
Why are you rendering per request instead of rendering per hour or per day? Because you would have way less compute as well.
Sure, yes. It's not something. I made this in a weekend. I just wanted to test the project out. You can have cache. They do have. COT actually has a section in the documentation about setting up the cache. So, yes.
I saw at the end of the previous slide you use like you have to explicitly state a variable must be mutable.
Yeah.
Using
Let mute, yes.
So I don't know if it's a stupid question, but this was considered a functional programming framework, or it just goes this private from functional programming?
I think by definition it is functional, isn't it? Rust. It is.
So a function is considered like a first procedure where you can pass it down to other functions.
Yes.
Cool.
Can I answer?
Yes, please go for it.
If you want to represent like your certain objects, you have similar primitive like strippers and
Enums, yeah. Rust is a lot more advanced than I did show here, but the really cool thing is you don't need to know all those really advanced Rust things to make something which is fast and performant. So yeah, that's it for my talk. Thank you very much everyone for coming. Okay, how many people did I convert to do that? Okay, one hand raised, very nice.
High five.